All right, kiddos, chapter 10, Common Core Practice. Away we go. That's an exponent right there. And exponents traditionally mean you just take that number and multiply it by itself that many times. So 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is going to be 343. How did I know that? I didn't. But what I did know is it's definitely not 49, it's definitely not 21, and it's definitely not 2100. So it's got to be A. It's got to be A. Or as Justin Timberlake would say, it's got to be A. All right, so we have, a parentheses connected to a 4 exponent. So I'm going to write out the parentheses 4 times. Inside each parentheses is -3, -3, -3, -3. And let's just do this one step at a time. -3 times -3 is +9. So why don't I do that again? -3 times -3 is +9. And +9 times +9 is 81. Actually, it was a whole lot easier than I was going to originally do. Now, 3 and 4 are the same type of problem. Take a look at them. You have inside of parentheses something to the something power, outside of the parentheses to the something power. So what I'm going to do is I'm going to do 13 the long way. I'm sorry, not 13. 3 the long way. And if I could figure out some type of shortcut in the meantime, then I'll use that shortcut for 4. I have a feeling I will. Just like in problem 2. In problem 2, we had a parentheses to the 4th power. So problem 3, we have a parentheses to the 4th power. So I'm going to write out parentheses 1, 2, 3, 4 times. Inside each parentheses, I have 2 12s. So 12 times 12, 12 times 12, 12 times 12, 12 times 12. How many 12s do I see there? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 12s. So 12 to the 8th power. I wonder if there's a way or a shortcut that I can do a 2 and a 4 and turn that into 8. Oh yeah, multiply. So it seems to me if I have something inside of parentheses with an exponent, and then right outside the parentheses another exponent, I multiply exponents. So let me use that same exact sentence to do 4. If I have something inside of a parentheses with an exponent, and then outside the parentheses another exponent, I multiply exponents. 8 times 6 is 48. Right? Yep. So I have 48t. Now the last thing I'd want to do is I'd want to take the parentheses and write that parentheses out 6 times, and inside each parentheses have t, 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 like 8 t's, and then 8 of them again, and 8 of them again, and then count up all my t's. I'm not a gossiper. I don't have that much tea. T means gossip. All right, so we got problem 5 here. More exponent nonsense to deal with. So let's use common sense. Yes, there are shortcuts, and yes, you can go to my Minute Math videos and see those shortcuts, but I'm going to use common sense to do these. Inside, I don't care the outside of the parentheses, not yet. Inside the parentheses, I have 2, 2, and then 2, 2, 2. So that's how many 2s? 5 of them. Outside the parentheses, I have 2, 2, and 2, 2, 2, 2, 2. That's 7 total. Two times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. There you have it. 5 you could just do in a calculator, but that's no fun. My calculator is up here, friends. This is how I like to do problems like 6. I like to view these types of problems as you have people living upstairs and people living downstairs, and they don't like each other, so they fight. I have 6 8.9s upstairs. I have 2 8.9s downstairs. Which side is more powerful? The top. How many more 8.9s live upstairs? Well, 4 more 8.9s live upstairs. I subtracted. On the bottom, I'm left with nothing. If you divide by 1, nothing changes, so I have 8.9 to the 4th. The trick behind these is if I have something in the numerator divided by something in the denominator and they're the same thing, subtract the exponents. And whichever side is more powerful, or whichever exponent's larger, after you subtract, keep the exponent and the number on that side. So using that logic, let's take a look at 7. I have negative 19 in parentheses upstairs. I have negative 19 in parentheses downstairs. I have 7 negative 19s upstairs, and I have 2 of them downstairs, which means upstairs, the numerator is more powerful. 7 minus 2 is 5. So I have negative 19 to the 5th upstairs over 1, and that over 1 is unnecessary. If 1's on the denominator or the bottom, it's unnecessary. Negative 19 to the 5th power. Now we're going to take what we did in problem 5 and problem 7 and do that with problem 8. Upstairs, I have in one room 8 5s. In another room upstairs, I have 6 5s. So if I have 8 5s and 6 5s, I add all of those 5s, and that gives me with 5 to the 14th. If two numbers are next to each other and they're the same base, add the exponents. If you're multiplying, add the exponents. On the bottom, I have 2 5s. The numerator is more powerful by how many? Well, 14 minus 2 is 12. So I have 5 to the 12 on top. I have nothing remaining on the bottom, so an invisible 1, which means A. Been doing a lot of these videos lately. All right, 9 is not too dissimilar from what we just did. 9 upstairs, you have 9 T's in one room, and in another room upstairs you have 12 T's. So if I have 9 T's over here, and you have 12 T's over here, and you add up all those T's, you have 21 T's. Downstairs, I have 6 T's in one room, and I have 5 T's in one room. It's a combined total of 11 T's because I add the exponents. When you have a letter on top that's the same as a letter on the bottom, you subtract the exponents. The top is more powerful, so keep it on the top in the numerator. 21 minus 11 is 10. 10 to the, or t to the 10th over 1 is just t to the 10th. B. Very similar to 8. Problem 10, on the other hand, we haven't done a problem like that yet. Negative exponents. Every exponent that we dealt with so far had a positive exponent. We haven't had a negative exponent. What does a negative exponent mean? Move it to the other side of the fraction bar. So you might look at 9 to the negative 3, and you might say, other side of the fraction bar, I don't see a fraction bar. Then make one. You can turn any number into a fraction by putting it over 1. So if I were to move that to the bottom, it would now become 9 to the positive 3 on the bottom and 1 over that. Now, unfortunately, that's not an option over here. They want us to actually do the math. So we have 3 9s. 9 times 9 is 81. 81 times 9 is 700 something. So 1 over 729. This is the way we should answer it, but that's not the way they wanted to answer it because they're crazy. Speaking of crazy, anything to the 0th power is 1. 91 to the 0th power is 1. Anything to the 0th power is 1. Anything to the 0th power is 1. Anything to the 0th power is 1. Write the power with a base of 7 that is equal to 49 to the negative 4th. Okay. This is going to be weird, and bear with me. This is an Algebra 1 problem, but I'm gonna take 49. I'm just gonna be creative and clever here. I'm gonna take 49 to the negative 4th. I'm just gonna focus on 49 only. 49 is the same as 7 squared, right? So 49 to the negative fourth is the same as 7 squared to the negative fourth. On the first page, I think it was, we had stuff living inside parentheses with an exponent taken to another exponent. And what we did is we multiplied exponents. When you multiply exponents here, you get 7 to the negative 8. Now, a lot of you might be like, I've never seen anything like that before. Well, this is one of those weird problems that, you could see like on SATs or PSSAs or whatever, and maybe you haven't seen a problem like this, so you have to think outside the box a little bit. What a lot of people might do is they might type that guy into their calculator, get some terrible, ugly decimal, and type all of your other options into the calculator, and B is going to get you the same ugly, terrible decimal. So, many ways to do it. That's just the way I did it, and I'm sticking to it. You can't stop me because, I'm on a computer and you're not. Well, actually, if you're watching this, you're on something. Speaking of ugly decimals, there are 1 times 10 to the 5th centimeters in a kilometer. That's true. How many centimeters are there in 8.6 kilometers? All right, I don't have a calculator. I do have my phone, but I'm going to try to avoid it. There are 1.0 times 10 to the 5th centimeters in 1 kilometer. How many centimeters are there in 8.6 kilometers? So I have to multiply 8.6. Well, this ain't so bad. 8.6 times 10 to the 5th is, I don't know. But 8.6 times 1 is 8.6. So I have 8.6 times 10 to the 5th. Okay? Now that's not an option here. They want it in standard form. So if I'm going to turn 8.6 times 10 to the 5th into a regular looking number, I'm going to rewrite out 8.6, and then I'm going to move the decimal to the right because it's a positive 5 times. 1, 2, 3, 4, 5. And I'm going to fill in those spots with zeros. So I have 86,000,000, which happens to be A. 860,000 centimeters. Okay? By the way, I'm going to use the word zero a lot in this section. And my cat's name right here is Zero. Say hello, Precious. Say hello, okay. Zero is the dog in the Nightmare Before Christmas, and so logically we named a cat Zero. Logic. A person breathes in about 2.5 times 10 to the negative 4th cubic meters of air per second. How long does it take to breathe in 2.9 cubic meters of air? All right, so to imagine what we're dealing with, a cubic meter of air is, just pretend what a meter is. It's like a yard, and turn that yard into a cube. So it's going to be a huge box, okay? So you need to find out how long it's going to take you to breathe in almost 3 of those boxes, okay? So it's going to take a while. The way that I'm going to do that mathematically is I'm going to do 2.9, because that's my 3 boxes, and almost 3 boxes, and I'm going to divide how much air I actually do breathe in per second. Now, normally if you had a calculator, you would just run straight to your calculator and do 2.9 divided by 2 parentheses, 2.5 times 10 to the negative 4th, close parentheses, enter, then you have your answer. I don't have a calculator on me, so I'm going to basically take the numbers that I have and kind of go with it. So, first things first, see that negative exponent right there? Negative exponent lives on the bottom, so let's move it to the top. So now what I have is 2.9 divided by 2.5 times 10 to the positive 4 up here. I don't know what 2.9 divided by 2.5 is, but it's going to be a little over 1. And looking at my numbers that I have up here, it's not going to be 2 something and it's not going to be 7 something. It's going to be a little over 1. So it's going to be 1.16. Where did I get that number? Because A is going to be 116 and D is going to be 116. So it's got to be one of those 116s. So I have 2.9 divided by 2.5 gives me 1.16 times 10 to the positive 4th now. Like I did in the last problem, I think it was the last problem, I take out my 1.16. move that decimal over 1, 2, 3, 4 times to the right, attach 4 zeros, and I have 11600, which is D. Again, 14 is not ideal without a calculator, but I may do without a calculator because I don't have one on me. I have Siri, but Siri she's an awful, nasty woman. It's my impression of somebody. I'm not allowed to say who. 15 is basically the easy version of 14. Take 1.91 times 10 to the positive 6, which means move it to the right. 1, 2, 3, 4, 5, 6. Oh, 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 oh. So the one with 4 zeros attached is my answer. I don't know where C came from, though. Okay. So we're going to do this without a calculator again. 7.37 times 10 to the 6 is going to move over 1, 2, 3, 4, 5, 6, which means I attach 1, 2, 3, 4 zeros. 3, 7, 7, 3, 7, 0, 0, 0, 0. That guy, 8.19 times 10 to the 5th means I move over 1, 2, 3, 4, 5, attach 3 zeros. 819,000. I am being asked to add them. God bless you. I am being asked to add them, so I'm going to add them without the use of a calculator. 737,000. I realize you can do all of this in a calculator, but like I said, I don't have one. I don't have one. So I'm going to add them. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 9 is 9. 7 plus 1 is 8. 3 plus 8 is 11. Carry the 1, 8. Now I have to put it back in scientific notation. So that dot would go right there. It's going to be a positive exponent. And I'm going to move it to the right. 1, 2, 3, 4, 5, 6 times. Calculator would be so much easier. And then that takes us to 7, where a calculator would be so much easier. Although this one's not so bad. I'm going to write this out as a fraction because we're dividing here. 2.6 times 10 to the negative 5th over 1.3 times 10 to the positive 6. Okay. Look, a negative exponent. I'm going to take that negative exponent and move it downstairs and make it a positive exponent. So now what I have, and I'm going to move this over here, is 2.6 over 1.3 times 10 to the 6th times 10 to the 5th. Okay? 2.6 divided by 1.3 is the same thing as doing 26 divided by 13, which is 2. And if I have 6 tens, our area code. And 5 tens, I have 10 11s, 11 tens. And if I want to write that in scientific notation, I have to bring that fella back up here, which means I have to make it negative again. And that gives me B. Again, a problem where a calculator would be so much more necessary, but we're doing this without a calculator, baby. I wonder if I could do 18 without doing anything. First off, it wants me to put it in scientific notation. You're not even scientific notation. Why? Because it's that number 0.7 is too small. I have to put my dot in between that 7 and that 7. So I have 0.00000007735, and the dot belongs in between 7 and 7. It's a negative exponent, which eliminates u. How many times do we move over? 1, 2, 3, 4, 5, 6, 7. So I have 7.735 times 10 to the negative 7. Okay. Fun. Problem 19, I have 3 times 10 to the negative 7 times 3 times 10 to the negative fifth. So let me rewrite that out and get rid of those parentheses, because if all I'm doing is just multiplying, I really don't need those parentheses. So I have 3 times 10 to the negative 7 times 3 times 10 to the negative fifth. Well, I'm multiplying straight across, so let's multiply those like terms. 3 times 3 is 9. If I want to keep this in scientific notation, it looks like what I have to do is make sure I don't move anything to the bottom. Even though I see negative exponents, and at first I want to say, move it to the other side of the fraction bar, we're not doing that. The other trick, the other shortcut, is when you're multiplying things of the same base, add the exponent. So 10 to the, add the exponent. Negative 7 plus negative 5 is negative 12. And there I have my answer. Yes, you could use a calculator, and I know I've said that 1,000 times, but we ain't. 20 is the same exact problem. If I write it out, I don't need those parentheses because all I'm doing is multiplying. 2 times 10 to the fourth times 1 times 10 to the eighth. Multiply like terms. 2 times 1 is 2. Okay? If I have 4 tens, and I'm multiplying or putting next to it 8 tens, I have 12 tens. Okay. Okay. What's the length of the bacterium in scientific notation? So I have 0.0016. Where does my dot belong in between the 1 and the 6? That's a change of 1, 2, 3. So I have 1.6 times 10 to the. It's going to be negative because that number right there is very small. And I moved 3 times, so negative 3, which is C. And that, ladies and germs, is the end of the multiple choice section. Now on to the not multiple choice section. And it doesn't start out friendly, it looks like. An apartment complex uses an average of 2 to the second times 3 to the fifth times 10 to the second gallons of water each month. So that's how much each one uses, right? No, the whole complex uses that. Each apartment in the complex uses an average of 2 to the second times 3 squared times 10 to the second gallons each month. How many apartments are there in the complex? So this is the total, and this is each apartment. So if we were to simplify this problem a little bit and say, an entire apartment complex uses 10 gallons of water and each apartment uses 2 gallons. How many apartments are there? You'd be like, oh, well, 10 divided by 2. Well, that's what we're going to do here. We're going to do the red stuff as our numerator, 2 to the second times 3 to the fifth. Can I undo? Will that let me undo? No. I have to do it. I have to get rid of the whole thing. Sloppiness is not what I'm about. 2 to the second times 3 to the fifth times 10 squared. That's the whole apartment complex. I'm going to divide 2 to the second. Well, that's easy. Times 3 to the second. That's not bad. Times 10 to the second. That's easy. Why am I saying that's easy for two of them? 2 to the second over 2 to the second just kills each other off. 10 to the third second, over 10 to the second kills each other off. That leaves me with 3 to the fifth over 3 squared. So again, you're now gone, and you're now gone. So I have 3 to the fifth over 3 squared. 3 to the over 3 to the. I have 5 threes upstairs, literally, apartments, and I have 2 threes downstairs. That leaves me with 3 threes upstairs over 1. Now, if I'm going to answer this in a real life term, 3 to the third is 27. I have 27 apartments. That's a clever problem. I like that. Never did that problem before, but I like it. I like it a lot. All right, we got ourselves some friendly problems here on the second half of the packet. 5 times 5 times 5 times 5 times 5 times 5 is 6 of them. 5 to the 6th power. Pi times pi is 2 of them. Z times z times z times z times z. I don't know how many I said, but there's 6 of them. Eight times 8 times 8 times 8 is 8 to the 4th. D to the 5th. Pretty nice. Pretty nice. Pretty nice. You build a model of the cube shown and make the sides 3 times as long. Write an expression for the volume of the model. Write your answer as a power. Okay. So this is, again, one of those weird Algebra 2 type problems, but you know what? I like it. I like it, I like it, I like it, I like it, I like it a lot. So, if it's going to be 3 times as long, it's going to be, so this new cube is going to be 3 times as long. So it's going to be 3x and 3x and 3x. The volume is going to be 3x times 3x times 3x. Okay, so A is asking me to write an expression for the volume of the model, write your answer as a power. So A is saying 3x times 3x times 3x. In other words, 3 times 3 times 3 is 3 to the 3rd. I have 3 3's there. And x times x times x, rest in peace, June 18th, is x to the 3rd. Simplify the expression, what B is asking us to do. 3 times 3 is 27, x to the 3rd. Weird problem. Weird problem. Another weird problem. I'm going to ignore that. Pretend that that's not there. 3 to the 8th over 3 squared is a number. So I have 8 3's on top, 2 on the bottom. Top's more powerful by how many? By 6. Now it wants us to compare that to, I don't know, to the 6. So 3 to the 6 equals, I don't know, to the 6. Well, x is 3. X is 3 because 3 to the 6 equals x to the 6th. And so the only difference there is the fact that you have 3 and you have x. That's it. I don't know how else to explain it. Maybe the fact that we showed our work explained it. I don't know. Another one of those weird Algebra 1 problems that you'll probably never see until Algebra 1, but you did it anyway and you're better for it. The sound intensity of a chainsaw is 10 to the 11th times greater than the quietest noise a person can hear. The sound intensity of a rustling leaf is 10 times greater than the quietest noise a person can hear. How many times more intense is the sound of the chainsaw than the sound of the rustling leaf? Well, if chainsaw is 10 to the 11th, and if rustling leaf is 10, invisible 1, that's 10 to the 10. How did I do that? Subtract exponents. At this stage now, you should be able to be like, oh, there's a 10 up here. There's 11 of them, actually, and there's 1 10 down there. There's 11 10s. There's 1 10. That's more powerful. By how many by 10? 10 to the 10th. Or 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros attached to it. I'm not sure how I'm going to answer that, but I just did. So I either have 10 to the 10th or 1 with 10 zeros attached to it. What, buddy? Boy, oh boy! My son's over there making some weird, strange sounds. Can't throw stuff at him. It's against the law. So simplify the expression. Finally, the problems that I enjoy. Let me see. Does d compare to anything? No. D to the 8th stays on top. M to the 7th over M to the 5th. Which M is more powerful? The top. By how many? 2. 7 minus 5 is 2. M to the 2nd, baby. 3 to the 4th over 3 squared. Which 3 is more powerful? The top. By how many? 2, baby. So I'm going to rewrite it because there's nothing on the bottom, which means the bottom is useless. I like putting my number first. D to the 8th, M squared. There you have it. There you have it. Without evaluating, order 6 to the 0th, 6 to the negative 3rd, and 6 to the 3rd from least to greatest. You're the smallest because negative exponents, the larger the negative exponent, the smaller the number. So you're the smallest, 6 to the negative 8. And then 0 is in between because 0 is in between negative 3 and 3. You're taking your exponents and you're listing them from least to greatest. Not so bad. Describe and correct the error in evaluating the expression. Oh, here's the problem. What's being taken to the negative power? 5. What did they do? Make it negative 5. So it should be 1 over 5 to the 3rd on the bottom, which is 1 over 5 times 5 times 5, which is 1 over 25. 125. What they did is they made the 5 negative because they were like, negative exponent, let's make the whole number negative. And that's not what you do, kids. That's not what you do. Simplify, write the expression using only positive exponents. All right. 10 is 10. Z is taken to the negative power. Well, negative exponents means I move it to the other side of the fraction bar. And you might say, what fraction bar? Let's make one. So z to the negative 2 moves to the bottom and becomes z to the positive 2. And that's my answer. That's my answer. And I'm sticking to it. Right, boy? You said, Let me see here. We got 8, which is 8. We've got y to the negative 3, which moves downstairs and becomes y to the positive 3. We have y to the negative 6, which moves upstairs and becomes y to the positive 6. I have 6 y's up here. I have 3 y's down there. The 6 y's up here is more powerful than the 3 y's down here, and that's a change of 3. So I end up with 8y to the 3rd over nothing. Subtract the exponents, which is just 8y to the 3rd. Love these problems. Love, 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 love them. Love them! So I have another big fraction bar, so let's just draw it out. 5 to the negative 4 moves it to the bottom. Y squared stays on top. Z to the 0th just means times 1. Because anything to the 0th power is 1. And z to the negative 5 moves up top. The only change is the fact that that 1 is no longer needed. So I have y squared up top. That 1 is no longer necessary. Z to the 5th up top. And 5 to the 4th on the bottom. Yeah. All right, so we have ourselves a metric ton. I have to find out how many grams are in a metric ton. And so what I'm going to do is I'm going to divide. So metric ton is my total amount, and I'm going to divide out the number of grams, which I made blue. Looking at this guy, grams is what I call my grandma. So what I'm going to do is I'm going to keep 10 to the 3rd upstairs. So let me make it red still. And I'm going to move 10 to the negative 3rd upstairs because it has a negative exponent. That's supposed to be a 3, but but the lag. 10 to the third times 10 to the third is 10 to the sixth. Over 1's useless. 10 to the 6 is the 1 with 1, 2, 3, 4, 5, 6 attached to it. A million. A million. Or as Lil Wayne would say, a milli. Really good rap song. Really good. Simple, but good. Terrible lyrics, though. I would not suggest you listen to that in front of Grams. Although my grandma would probably like it. She's 93. Good for you, Grandma. You live that best life. Tell whether the number is written in scientific notation. Oh, easy. Easy. I'm not going to explain using numbers. Yes, because that number lives in between 1 and 9.999999. That number is 10, and that's a number. 15 is also a yes, for the same reasons. That number is in between 1 and 9.999999. That number is 10, and that is just a number. That is a no, because that number is not in between 1 and 1.99 or 9.9999. So that's a no. No. It's a no. Alright, kiddos. Last page. Describe and correct the error in writing the number in standard form. I see it immediately. See the negative exponent? Negative exponent means my number is not supposed to get bigger, it's supposed to get smaller. So I should have gone this way. 1, 2, 3, 4, 5, 6. Put a dot. 1, 2, 3, 4, 5. And it should end up being 0.000053. They went the wrong way. Suppose the average grain of salt weighs 0.000058 gram. What is the weight in grams of 12 million grains of salt? Figures. It's the last problem, and I'm probably going to need a calculator. No big deal. Suppose so each grain of salt is 0.000058, and I have 12 million of them. Did I have the right? Okay, good. So here we go. 0.000058 times 12 million.
It's 696.
There you have it. Okay. Do I have to answer in scientific notation? No, but I will anyway. Put the dot there. Burp, burp. 6.96 times 10 squared. And that, boys and girls, is the end of that. All that Common Core, Chapter 10, Dunzo. Like and subscribe, and I've done so many of these videos in the last couple days. Please subscribe, please. I need that YouTube money so bad. Please click that subscribe button, like, comment below, and I'll probably won't comment back. Well, I might. Somebody the other day said, I like your videos, will you be my friend? I didn't respond yet. Bye!